Namaste. Namaste everyone. Welcome to second PC physics class. We were studying about atoms. In the last class we derived equations for radius, energy and velocity. Remember? So today we will recap it once and we will move on to the wavelength of light emitted when the electron jumps from one orbit to another. But we will recap all the formulas, right? Namaste. Hope you are doing well. So we have completed many chapters now. You see, we have started from ray optics and we have completed the wave optics, very important chapter, and it's not so easy to understand. Once you get the concept in wave optics, what is path difference, phase difference, and once you keep moving, then it goes very fast. We studied polarization in that chapter and we completed dual nature. Of course, that is not a very tough chapter, but very important again. Now we are coming to atoms, and two more chapters we have in this part, modern physics. It's the next part 2. That is, one is nuclei and another is semiconductors. Very easy chapters and very small chapters. If you compare it to the other part, they are very, very easy and very small. Okay, so shall we recap all the formulas related to radius of the electron and velocity, energy and all. Okay, take a pen and paper, don't waste the time. With the pen and paper, whatever I say, you just keep on writing. So see the mobile as less as possible. Write it because you can listen whatever I say. Okay, what did we study? According to Niels Bohr, right? An electron revolves around the nucleus in only non-radiating orbits. Non-radiating orbits are those where the electrons keep on revolving and they don't lose any energy. If they happen to lose energy, they go to another non-radiating orbit. And those positions of non-radiating orbits are done according to the condition, that is quantization rule given by Bohr. Angular momentum of the electron must be equal to nh by 2 pi, where n can take the values 1, 2, 3, 4, only integers and no other values. It cannot have any other value other than integers. And this is not given by Rutherford. This was given by only Bohr, right? Now, another condition given by him, that is centripetal force m squared by r, is given by the electrostatic force of attraction between positively charged nucleus, negatively charged electron, but we are writing only magnitude because since the electron is negatively charged, it is attracted towards the nucleus, so it is in the direction of centripetal force. So direction of this force and direction of centripetal force are same. So this is r squared, 1 by 4 pi epsilon naught q1 q2 by r squared. That is the electrostatic force between two charged particles. Okay, so from this equation, and we will have a small diagram. I think you can see it here. If I draw this here, yeah, or I will draw it here. This is better. So a nucleus of atomic number Z, but we are applying it only for hydrogen. You know it because Bohr applied all his theory to the hydrogen atom. Ze, and here is electron. So actually this is 1e, right? Not Ze, but I will take Z. In the exam you write only E. And it is proton for hydrogen, 1 proton. This is minus E, and its speed is V, and its mass is m. And the radius of the circular path r. 1 r gets cancelled. And here you can get ready with V. What is V? V is equal to nh by 2 pi mr. And you can substitute this here. You know the procedure, right? So from the beginning we are doing from radius, velocity and energy. Then we will have to move on to the next part. Okay. What else then? Yeah, mv squared by r is equal to so much m v squared. From here, v is nh by 2 pi mr, n square, h square, 4 pi square and m square, r square. This is what is done, right? N square, h square, 4 pi square, m square, r square is equal to, m square is over, this r has been already cancelled here, z square divided by, E is the charge of electron, z is atomic number. Z doesn't appear when you do that in the final exam, but now I retained, because if you want to know where z is, you have to retain it for the entrance exam, for 4 pi epsilon naught r. But we want the expression for r, so I will bring r here, rest of the things to the right hand side. What is the radius of the electron? Z square into 4 pi squared m squared r squared divided by m n square h square. What else? Nothing else. Everything is perfect now. 4 pi epsilon naught r. 4 pi epsilon naught r. Because r comes here, remaining things here. So 1 m gets cancelled, remains here. 1 anything 4 gets cancelled, 1 pi remains here. And what is the remaining thing? Pi was 1. Again it has gone wrong. Here one more r we have, right? This epsilon r, so something else. 1 minute. I have made it wrong, right? So this is wrong. Yes. What you have to do? M. I have to maintain r. So here is I have r square, right? 1 r squared and 1 r gets cancelled. 1 r remains here. I have to revise it properly. And r, I have to bring r here. Yes, r here. And remaining things here. 4 pi epsilon naught m n square h square. Yes, 4 pi epsilon naught m n square h square. Then r is here, z square here, z square 4 pi square m square. Yes, this z square here, 4 pi m square here, radius here, one radius has been cancelled, 4 pi epsilon here. So 4 gets cancelled, pi remains here and 1 m remains here. So epsilon naught n square h square, that's what we want to get. Epsilon naught n square h square divided by pi m z e square. Correct? Pi m z e square. Z, where is e square? Z e square, yes. This z e square should come here, right? So epsilon naught n square h square divided by pi m z e square. So this is the radius of the circular path. And you know that radius is directly proportional to n square. Radius is directly proportional to n square. That means if the first orbit of radius of hydrogen atom is r, next radius will be 4r, next will be 9r, 16r, 25r. So it is directly proportional to square of the quantum number. As you move to the outer orbits, it is directly proportional to n square. Inversely proportional to z. But if you apply it for hydrogen atom, it is z equal to 1. So when Bohr applied this to the hydrogen atom, he got the answer as A naught. R is taken as A naught. Substitute all these values, 0.53 angstroms. Right? So that is the radius of the first orbit of hydrogen atom. What is the radius of the second orbit? Into 4. Because 2 square. Earlier you have substituted it as 1 square. Okay. Then I want velocity. How do you get velocity? Substitute the formula for R in the velocity equation. V is equal to nh by 2 pi m r. What is radius? Radius is this one, epsilon naught n square h square divided by pi m z e square. Correct? Epsilon naught n square h square pi m z e square. No z in the exam, right? What is V? V is equal to 1n getting cancelled and 1h getting cancelled. 1 pi completely cancelled, m completely cancelled. Z e square divided by 2 epsilon naught nh. This is the velocity equation. And velocity is inversely proportional to n. That means as the electron moves to the outer and outer orbits, its speed goes on decreasing. And it becomes more and more free. If it goes to the most outer orbit, that means just out of the material, then its speed will be 0. Kinetic energy is 0. So it is, that means n is equal to infinity, the last energy value or the last orbit. Okay, velocity over energy. How do you analyze the energy? Electron revolving around the nucleus has got two energies, kinetic energy as well as potential energy. Potential energy is negative because it is bound to the nucleus, whereas kinetic energy is positive, it is moving. So if you want to know the total energy of the electron revolving around the nucleus, it is potential plus kinetic. Now how do you write potential energy? 1 by 4 pi epsilon naught Q1 Q2 by R only, no R squared for potential energy. Those who have not studied it, you are going to study it, because if the lockdown continues like this, definitely we can complete the second part. Second part within a few days, 15 days, you can complete the second part, no problem. And the remaining part, that is the first which is very important, but there we can't run like this now. We can finish some chapters there also. I think if I get 1.5 or 2 months, I can complete everything, right? So let us see what we do. But by the way, we will have some CET classes also in between, right? I am giving you CET papers and you can study that also. Those who are really interested can move forward. Those who are not interested, many people are not watching the videos, doing nothing, and they simply, some people simply see this and they don't do anything else, no work. And those people are going to be in a big trouble once the classes start, because you will not have any time for other works, right? So it will be high hectic schedule once the classes start. So if you want to avoid it, better you watch the videos now. Okay. So potential energy plus kinetic energy, right? Now if you want to write what is kinetic energy, again go for which one? Centripetal force, because there you get m squared. M squared by R is equal to 1 by 4 pi epsilon naught. That force of attraction between the positively charged nucleus and negatively charged electron, that is Ze into E by R squared. 1 R gets cancelled. Same procedure here. What did we do here? Okay, now what is kinetic energy? Kinetic energy is half m square. So multiply this by half, because m square is ready, multiply it by half. What you will get? Z square divided by 8 pi epsilon naught R. This is kinetic energy. Now how do you write potential energy? Potential energy of an electron revolving around the nucleus is 1 by 4 pi epsilon naught Q1 Q2 by simple R. 1 by 4 pi epsilon naught Q1 Q2, because it is bound to the nucleus. So now you have to take the negative sign. Q1 Q2 by distance R. This is so what is potential energy? We have taken it as EP, right? EP. So what is EP? Potential energy. I think you can see it here. Potential energy EP is equal to minus Z square divided by 4 pi epsilon naught R. See here, which is greater? Potential energy is greater and being negative. Kinetic energy is smaller because it is 1 by 8, right? Where is it? 1 by 8. Positive. But total is negative because potential energy being negative is greater. So it is greater than kinetic energy, even though kinetic energy is positive. When we make the sum, we get answer negative. So, and one more thing I can write it here. You see, potential energy is 2 times the kinetic energy, but kinetic energy is positive, so give a minus sign so that you will get potential energy. These things are very much needed when we solve the entrance exam problems. Okay, so what is the total energy? We will write the total energy as kinetic plus potential. Shall we write potential first? Anything, kinetic we will write. Z square divided by 8 pi epsilon naught R minus, of course it is plus, but this is minus, Z square divided by 4 pi epsilon naught R. Take everything except 8 and 4 outside the bracket. E is equal to Z square divided by pi epsilon naught R into 1 by 8 minus 1 by 4. Right. Okay, what else you get? This is 1 by 8, 8 is common, this is 4, this is 1 and this is 2 minus 2, so minus 1 by 8. So what you will get here? E is equal to minus Z square divided by 8 pi epsilon naught R. So final answer is same as kinetic energy, but R you have to substitute. Final answer is same as kinetic energy, but the thing is it is negative. It is, I have given yesterday one example. Minus 100 plus 50 is equal to minus 50 answer. This is same as this one but with negative sign. Okay, so substitute for R. E is equal to minus ZD square divided by 8 pi epsilon naught R. What is R? Epsilon naught n square s square pi m ZD square. So this is what you have to do while studying for the exam. You have to study all the derivations at once. Because when you study the derivation for radius, if you are very good in deriving radius, when you study energy, you will forget the radius. So you must be able to put everything in a single paper. Radius, velocity, energy and wave number. Next one. Okay, wave number is easy, no problem. You must know the equation for energy, that's all. So R is over here. What are the things which will get cancelled? Pi gets cancelled. Okay, then nothing, right? So minus z square e to the power 4. So total energy is minus z square e to the power 4 m. Z square e to the power 4 m divided by 8 epsilon naught square n square h square. This is the equation for energy of the electron any nth orbit, because it is inversely proportional to n square. Bohr used this formula and applied it for hydrogen atom, and he found that the energy of the electron, he got the answer for energy of the electron. And let me rub this now. Okay, I will clean the board and then we will continue. So he got the energy of the electron in the first orbit of hydrogen atom, and he put it in electron volt form, and it was found to be something like energy of the electron in the first orbit of hydrogen atom, what you call ground state. By putting n equal to 1 and z equal to 1, it is minus 13.6 eV, right? This is the energy. Now what is the energy in the second energy level? Minus 13.6 eV. Everything is same except n is equal to 2 square by 4, that is minus 3.4. So energy in the second energy state, minus 13.6 divided by 4, 2 square, minus 3.4 electron volt. In the third energy level, it is minus 13.6 divided by 9, that is the minus 1.51, something like this, electron volt. So like this way it goes on. And his explanation, any electron in the non-radiating orbit doesn't radiate an energy, and if it emits energy, it doesn't continue that, it goes to the next energy state. And the difference in the energy is emitted in the form of electromagnetic radiation, right? And suppose it is an electromagnetic radiation, how can you explain the electromagnetic spectrum emitted by hydrogen using Bohr's theory? Bohr successfully explained the electromagnetic spectrum of hydrogen. What do you mean by electromagnetic spectrum of hydrogen? You have to take hydrogen in a narrow tube like this and apply 2 electrodes and connect a small coil here, heat the coil, coil emits electron. That is what is called thermionic emission. And these electrons were, so you have to have a coil here, sorry, not here, because electron has to be repelled by the negative of the battery and attracted towards the positive of the battery. So if a coil is heated here, coil gets heated and it emits electrons, and those electrons are made to pass through the hydrogen gas. So this is hydrogen. Hydrogen is taken in a small tube in low pressures, and electron is made to move through the hydrogen by heating a coil. And when the electron moves through the hydrogen, these electrons will go and hit the hydrogen atoms. And when the electron hits the hydrogen atom, electron loses kinetic energy. Electron in the hydrogen atom, a small electron, right? It absorbs the kinetic energy of these electrons, gains the energy, goes to the higher energy state, and after some time it comes back. When it comes back, it emits energy in the form of radiation. And that radiation coming out of this tube by the different electrons when they undergo transition from higher energy level to the lower energy level. For example, if an electron is found in the ground state, minus 13.6 electron volt, that means innermost orbit, right? And if this electron is simply revolving around this nucleus here, its energy is minus 13.6. Suppose when I heat this coil and make the electron to move, suppose that electron gains an energy of 10.4 electron volt, and by absorbing that by having the kinetic energy of 10.4 electron volt, that electron hits the hydrogen atom. Hydrogen atom absorbs that energy And electron inside the hydrogen atom, now it is excited. It has more energy. It goes to the next energy state. So it goes to the next energy level. Say next energy level has an energy of minus 3.4 electron volt. It has gained energy, gone to this level, now it starts revolving here. But remember, always higher energy state is not stable. Electrons don't try to remain in the higher energy state for a longer time. They leave that energy back and come back to the lower energy state. But when they come back to the lower energy state, they emit the energy in the form of electromagnetic radiation, H nu. That is what we see coming out of this tube. That is the light emitted from the hydrogen. If you pass that light through a prism and observe the spectrum, you see different colored lights. Some are seen, some are not seen to the naked eye, and there are so many radiations. That is called electromagnetic spectrum. And this was practically observed even before Bohr gave the theory. The hydrogen spectrum was already studied, and surprisingly it was found that when the light from the hydrogen gas is viewed by passing it through a prism or any other spectrum method, dispersion method, then it is found that the spectrum contained different colored lines. That is called line spectrum. You see the spectrum of sun, right? How is the spectrum of sun? Rainbow itself is the example for the spectrum of sun. It's a continuous spectrum. What do you mean by continuous spectrum? If you observe a rainbow, you can see at one extreme end violet color, little bit, then blue, then yellow, something like that. And finally it is not immediately yellow, so you will get yellow somewhere in the middle, then last red. Do you have any clear cut packages of red, yellow, blue, green? No. Red gradually changes into orange, orange changes into yellow, yellow into something else, finally blue, green and violet and something like that. It is a gradual change. There is no break in between. That is called continuous spectrum. Now, what about the spectrum observed from hydrogen? It is not continuous. You don't have continuous colors of light. You have a particular color of light, then a break. Again another line of color. So, spectrum of sunlight is a continuous one. You have continuous colors starting from red, orange, yellow like this, finally blue, violet, something like that. But here you get lines. That is why it is called line spectrum. You get colored lines. In between, the gap between the two lines will be dark. That is called line spectrum. Of course, every spectrum, the light emitted from every source is a characteristic of the source itself. If you pass the light from a sodium lamp, you have yellow lights in the street lights. You might have seen some of the street lights are yellow in color. That is sodium lamp. So if you pass that sodium lamp to the prism and observe the spectrum, it is a line spectrum. So if you see the cooking gas flame in your house, right? Pass the light from the cooking gas flame through a prism and observe it. Of course, it is not so easy. I'm just saying it. And if I pass the light from the cooking gas flame and observe this dispersion spectrum, you will find that it is a band spectrum. What do you mean by band? Clear cut red color, continuous. Then a break. Then yellow, break, orange, break, blue, break, violet, something. That is a clear-cut break. It is not like a rainbow. So every source of light, from where does it come? Every source of light has its own spectrum, its own distribution of colors. Similarly, hydrogen has got line spectrum, already discovered even before Bohr gave the theory. But Bohr successfully explained how that spectrum has arisen. How? That is like this. So, he says when the electron jumps from higher energy level to the lower energy level, say this is higher energy level N2, this is N1. I am not saying this is second energy level or first energy level. Simply N2 means higher energy level. N1 means lower. Suppose an electron jumps from 7th orbit to 5th orbit, 6th orbit to 5th orbit, second orbit to first orbit. So second becomes N2, first becomes N1. 7th to 5th orbit, 7 becomes N2, 5th orbit becomes N1. So when it jumps, it gives that energy difference in the form of electromagnetic radiations of packets of energy, what you call H nu. Now, what is the wavelength of light emitted? When the electron undergoes transition from one orbit to another, you have used this formula in first PU chemistry, we will derive it very easily, right? Suppose an electron is in the ground state. Ground state means innermost orbit. Nucleus, and this is the circular path, radius r, and this is r, n equal to 1, first orbit. And if it is in the second orbit here, it jumps. When it jumps, it emits that energy in the form of h nu, correct? Now, this is called n2 and this is called n1. You know the formula for energy of the electron in any nth state, that you have to remember. What is the energy of the electron in any nth state? Minus z square e to the power 4m divided by 8 epsilon naught square n square h square. This is the energy in the nth state. Now, when the electron is in the higher orbit, that is called n2, maybe 7 to 5, 3 to 2, 11 to 10, any transition. Electron may jump from any higher energy level to lower energy level, and that difference in energy must be given in some or other form. Now we say that it is electromagnetic radiation. When it is in the higher energy level, En2, what I have to change in this? Only this one. All the other things are constants. So when the electron is in the higher energy state, its energy is given by minus z square. Of course, it is 1, right? It is hydrogen atom. So shall I put it as 1 now? At least now I leave this as 1. Minus z square e to the power 4 m divided by 8 epsilon naught square n2 square h square. That's all. What else is different in the second energy state? Nothing. Everything is same. Charge of electron doesn't change, mass of electron doesn't change, permittivity is same, and h is Planck's constant same. What is the energy by the time it reaches to the first energy state? En1, energy in the first state, minus z square, 1 square, same atom, hydrogen only, it has not gone to some other atom, it is in the same hydrogen atom, minus e to the power 4m divided by 8 epsilon naught square, n1 square, h square. Okay, so I will show it with a simple diagram like this. I will show it in the energy level diagram. This is the energy of the electron in the second position, higher position, energy of the electron in the lower position. When it jumps, it emits in the form of h nu, packets of energy. Nu is the frequency of electromagnetic radiation. Okay, what is the energy difference? So energy emitted is equal to h nu, it should be h nu, that is equal to En2 minus En1. Do you agree? Higher energy level minus low. For example, if it is in the ground state, 13.6 electron. If it is in the first state, minus 3.4. Minus 3.4 is greater. In the last class, we were discussing about this. Minus 13.6 is lesser. So what is the energy emitted? Minus 3.4 minus of minus 13.6. And this comes to 10.2 plus. This is plus minus, so it is 10.2 electron volt. That should be h nu. That should be in the form of electromagnetic radiation. Okay, right. This may not be the value exactly. Any value, right? So that En2 minus En1. So h nu is equal to, what is En2? Everything we have the same quantities here except n1 square and n2 square, right? So shall I write everything minus or I will write like this, En2 minus En1. So this is first, right? Okay, minus I'll write e to the power 4m divided by 8 epsilon naught square h square. This is over 1 by n2 square minus, in this, minus everything is taken outside, 1 by n1 square. Correct? All the common terms, here 1 by n2 square, minus I have taken outside, minus this one 1 by n square. Now take this minus inside. What is h nu? H nu is equal to, hope you are following, right? H nu is equal to, take the minus sign inside, e to the power 4m divided by 8 epsilon naught square h square into, when I take minus here, 1 by n2 square becomes minus, this becomes plus. So shall I reverse it? 1 by n1 square minus 1 by n2 square, correct? it is reversed, minus this one, this plus. Now you see h nu is equal to, nu I will write, frequency of electromagnetic radiation emitted. What is the frequency of radiation emitted when the electron jumps from higher energy level to the lower energy level? Right? What is the frequency? Nu is equal to e to the power 4 m divided by 8 epsilon naught square h cube. We have forgotten anything? No, isn't it? Yeah. H cube into 1 by n1 square minus 1 by n2 square. Now, if I want the wavelength, what I can do? You know, nu is equal to c by lambda, this formula, right? We write h nu, energy as h nu, hc by lambda. So, nu is equal to c by lambda. So, shall I write this as c by lambda? C by lambda is equal to this one, e to the power 4 m divided by 8 epsilon naught square h cube into 1 by n1 square minus 1 by n2 square. Of course, I could have written the c by lambda here only, no problem. What is 1 by lambda? 1 by lambda is equal to plus e to the power 4 m divided by 8 epsilon naught square h cube c. C here. 1 by n1 square minus 1 by n2 square. Now you see this. E to the power 4 constant. 1.602 into 10 to the power minus 19. M constant. 9.1 into 10 to the power minus 31 kg. Epsilon naught 8.854 into 10 to the power minus 12. H 6.6 into 10 to the power minus 34. C 3 into 10 to the power 8. How many constants you see? You practice it and try to remember. When we apply it, we will come to know, because H already you know. 6.6 into 10 to the power minus 34 joule second. C 3 into 10 to the power 8. Mass of electron already we have studied, 9.1 into 10 to the power minus 31. Charge of electron we know, 1.602 into 10 to the power minus 19. Only epsilon naught 8.854 into 10 to the power minus 12. Substitute all the values and put it as a single constant. What is the answer? 1 by lambda is equal to R into RH, I will write RH for hydrogen, 1 by n1 square minus 1 by n2 square, where RH is equal to the whole constant, e to the power 4 m divided by 8 epsilon naught square h cube c, and it is equal to 1.09 something, 1.01 something, 1.09 into 10 to the power, so 1.0 something like this, yes, 10 to the power 7 meter to the power minus 1. I will tell you why. It's called Rydberg constant. Rydberg constant for hydrogen. Sir, why hydrogen? Because Z is treated as 1. If Z is 2, then where did we lose Z? Where did we leave Z? Here. If Z was, because it comes in the numerator only, always. So if Z is 2, it would have been 4 times more, because Z square we have. That is put as 1 square. So this formula, remember this one? You have used in chemistry, right? So Rydberg, the wavelength of the radiation emitted when the electron jumps from one of the higher orbits to the lower orbit is 1 by lambda is equal to RH, Rydberg constant for hydrogen, into 1 by n1 square minus 1 by n2 square. This is a very, very important formula. Using this formula, Bohr was able to explain all the electromagnetic spectrum, or the electromagnetic spectrum of hydrogen gas. As if I told in that case, when hydrogen is taken in a tube and when the electron is made to pass, an energy is supplied to the atom, it emits some energy in the form of light, that atom, and when the hydrogen atom emits the light and the energy in the form of electromagnetic radiation, that is studied. And how do you get different colored lines and what is their wavelength? Formula is given by Bohr. And when the different values are substituted in the formula and they are calculated, and the wavelength obtained using Bohr's formulas and the wavelength calculated using practical observation were found to be true. And again, Bohr's theory was found to be successful. because it could explain what practically is seen. Practically seen thing is the spectrum of hydrogen. That is true. It is explained successfully. How? We will see a little bit of that. Now, shall I take that formula? Hope you have understood this. This is another derivation. Radius derivation, energy derivation, wave number. That 1 by lambda is called wave number. What do you mean by wave number? Now you will come to know, all the things what you have studied in first PhD will come here also. That different spectrum of hydrogen atom, right? Spectral series. 1 by lambda is called nu bar, not frequency. It is called wave number. Wave number. Okay, I will write completely. Is equal to RH, Rydberg constant for hydrogen, 1 by n1 square minus 1 by n2 square. That is the formula. Now, the formula RH value, that is Rydberg constant for hydrogen, is 1.09 into 10 to the power 7 meter to the power minus 1. Why? Because it is 1 by lambda. Left hand side, right hand side, dimensionally must be correct. Here n1 and n2 don't have any dimensions. What are n1 and n2? n1 and n2 are the simple numbers which will tell you whether the electron is in the first orbit, second orbit, quantum numbers. nh by 2 pi. N stands for 1 means 1h by 2 pi. N has no other significance other than saying that the quantum, the angular momentum should be 1, it should be double, it should be triple, only numbers. If this has no dimension, RH must have the dimension of 1 by lambda. Wavelength meters. What is RH? Meter to the power minus 1. What is wave number? Of course, you don't have that definition in the syllabus. It is a number of waves that can be accommodated within a certain unit length. That is called wave number. Number of waves within a unit length. Sir, what do you mean by that? Suppose this is 1 meter distance. Okay? Suppose a wave has a wavelength of 0.2 meters. Then what is 1 by 0.2? It is 5, right? What do you mean by 5? You can accommodate such waves, 5 waves within a distance of 1 meter like this. Because one wave measures a length of 0.2 meters. 0.2, 0.2, 0.2, 0.2, 0.2, 5 times gives 1 meter. 5 waves can be accommodated. That is what is nu bar. Number of waves accommodated in a unit distance. Of course, it is not a definition, but you can understand it like this. That is wave number. It is equal to 1 by lambda into 1 by n1 square minus 1 by n2 square. Remember, n2 is the quantum number of the higher energy state. It is not the quantum number of second state, higher energy state, and n1 is the quantum number of lower energy state. So when you draw the energy level diagram for hydrogen spectrum, and suppose you know that energy is inversely proportional to square of the quantum number. Try to remember the formula for energy also. Minus z square e to the power 4m 8 epsilon naught square n square h square. That is the formula for energy. It is inversely proportional to square of the quantum number. So if minus 13.6 electron volt is the first energy state, ground state energy of the hydrogen atom, what is energy in the next energy level? So if the electron is in the next energy level, we will put that energy in different levels, right? Just a graph. It is not that electrons are found in different shelves like this. It is just a graph, just imagination. Minus 13.6 divided by 2 square. This is by 1 square. By putting 1 square here. Minus 3.4. Next energy state will be very close, because when you divide a certain energy, minus 13.6, by 1 square, by 2 square, by 3 square, by 4 square, you see in the denominator it will be 1, next is 4, next is 9, next is 16, see the number growing, next is 25, next is 36, it is growing, right, denominator. So what happens to the last energies? They become lesser and lesser quickly. What do you mean by that? 1 by energy by 2 square, energy by 1 square, energy by 2 square, 1 and 1 by 4. Next one, 1 by 9, it is not 1 by 8, 1 by 9. Next one, it is not 1 by 12 or so, it is 1 by 16. So energy values are shrinking. That is why you have to have a difference of lesser and lesser as you move to the higher energy levels. So these two are far away. This is very less. You just calculate this. What is the difference between 1 by 4 and 1? What is the difference between 1 by 4 and 1 by 9? Calculate it. You will get it. What is the difference between 1 by 9 and 1 by 16? 1 by 16 and 1 by 25. The gap becomes lesser and lesser. 1 by 25 and 1 by 36. Still closer. So energy levels will come closer and closer. Okay, like this. So here closer, again closer. That means at the higher and higher energy levels, orbits are very crowded. The first orbit and the next orbit are far away. Next one little closer, 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 closer. Then become almost continuous, right? Almost very closer. So if I go on doing it like this, suppose this is the last one. Minus 13.6 by 2 square, this corresponds to minus 13.6 by 3 square, so on. Minus 13.6 by infinity square, that is 0. Last one. What do you mean by electron going to this energy level to this energy? Its energy has become 0. It has just come out of the material. In photoelectric we study this, right? If it has just come out of the material, it has nothing kinetic energy remaining. Because you have supplied only that much of energy which is needed to just come out. So that is the condition here. This corresponds to n equal to 1, n equal to 2, n equal to 3, n equal to 4, and this one n equal to 5, so on, n equal to infinity. This putting all the electrons in the different energy levels like this, Bohr was able to explain how the spectrum is seen practically and how can my theory explain, Bohr's theory can explain clearly the different spectral series. That we will see it in the next class. Hope you will read all these things. Derivations are very, very important. Definitely you will get a derivation in the exam or a problem, very simple problem from this chapter. And even for entrance exam, you will have simple questions, not very tough. So hope you will study all of them. So try to study the derivations before coming to the next class. We will meet in the next class with the hydrogen spectrum explanation given by Bohr, and that almost completes all the chapter of atoms, right? It's a very simple chapter. Okay, we will meet in the next class with the Bohr's explanation on hydrogen spectrum. Till then, take care of yourself and keep studying, don't waste the time. Thanks for watching my class. Thank you. Subscribe my videos, right, channel. Thank you.